Hello everyone. So today we're gonna be doing a question with that deals with probability. And so let's go ahead and read the question. So it says that there's 100 homes. There's a real estate company, and they pick 100 homes, or they have 100 homes. Some of these homes have fireplaces, some of them have garages, and some of them have neither. And as you can see over here, they have conveniently displayed for us all the information in a little table so that we may be able to see what's going on with the data. So as we can see over here, these numbers, so for example, let's look at the number 50. What does the number 50 mean? It means it gives us the number of houses that have garages and fireplaces. And for example, if we look at the 10 over here, well, that's the number. So you match the column or the column with the row. So this is the no garage row intersecting with the no fireplace column, and that gives us 10. So that means that out of those 100 houses, there is 10 houses which have no fireplaces and no garages. So what is the first question asking? It says, what is the probability that the home selected does not have a fireplace? So here's a keyword in the question, probability. So how do we calculate the probability? Just to give you a reminder, the formula for probability is given by x over n. Now, depending on the type of textbook that you're using, that formula varies. Some textbooks, instead of using x, use other variables, but I think I've come all across many textbooks, and they almost always use n for the sample size or the sample space. So in this case, our sample space is the 100 homes. So that's how many homes we have in our sample. And x being the number of houses which fit a certain criteria. So for the first part of the question, it says, what is the probability of that the home does not have a fireplace? So how do we denote not having a fireplace? Well, we denote that with F bar. So as you can see over here, they've labeled no fireplace as having a bar on top. So we call that, you can think of it as the opposite of having a fireplace. So if having a fireplace is denoted by F, then not having a fireplace is denoted by F bar, as you can see over here. All right, so, and that's all we need over here. So this reads exactly from left to right, the probability of the house not having a fireplace. So if we select one house at random, that's what the first part of the question says. It says if we select one house out of these 100 homes, what is the probability that it is going to have a fireplace? So in this case, my x is gonna be the number of houses that do not have a fireplace. So I'm gonna go look at the F bar column here. And what do I see? How do I know which of these four numbers to pick? Is it the 50? Is it the 10? Is it the 30? Or is it the other 10? Well, the answer here is that we're gonna be looking down the column of the no fireplace, which means that we want absolutely every house that does not have a fireplace. Now we're completely disregarding if it has a garage or no garage, because that does not concern us right now. We just want to know how many houses that have no fireplace. So the answer to that is actually 40. 40. So we have 40 houses that have no fireplace. So in that case, my x, if we were to follow this formula over here, my x would be 40, and my n, which is my sample space, let me just write that here on the side, is equal to 100, and it will stay the same. It'll always be 100 for all the parts of the question, so that doesn't change. So 100. So we divide those two together and we get 0.4, or 40%. 40%. So there is a 40% chance that, let's say I'm walking down the street and all these 100 houses are on the same street. So let's say I'm walking down the street and I enter a random one. What is the probability that when I enter, I'm not gonna find a fireplace? And the probability seems to be less than 50%, so it's pretty slim that I'm gonna walk in and not find a fireplace. So for the second part, they ask us to calculate the probability that the home has a fireplace or a garage. Now there's a very important word, and that is or. Is that it's equivalent to, an or is equivalent to really addition. So what I want over here is the addition of actually several probabilities. Now what is the probability of, so it says, so here's how we write this: fireplace or garage. So you're gonna write F or G, right? So I want to calculate the probability of having a fireplace or a garage. Now that probability is made up of how many probabilities? Well, let's just think here. So I can walk into a home and I can find a fireplace and no garage. So I'm gonna use this symbol over here for and. So fireplace and no garage. So that's my first probability, which still satisfies the condition because it says fireplace or garage. So it is very much possible that I can walk into the home and find a fireplace but no garage. It's also possible that I might walk into the home that has no fireplace but has a garage. That still satisfies the condition that they've provided us. And finally, I can walk into the home and then find out that it actually has both a fireplace and a garage, because that is still valid in my, so it says fireplace or garage. Well, guess what? Having a fireplace and a garage, it still has either one or the other, so it still satisfies the condition. So if I'm gonna calculate that, I'm gonna take it one step at a. So what is the probability of me finding a house that has a fireplace and a garage? So I go back to my little table over here and I check the conditions. So which row and which column are gonna intersect with each other? Well, I'm gonna go down this column right here, and I'm gonna go across the row of no garage. So guess where the intersection happens? It happens over here. So that 10 over here is how many houses that have fireplaces and no garages. So to calculate the probability of that, I'm gonna use my probability formula again, which says that 10 houses out of 100 will give me the probability of finding a fireplace and no garage. Next probability, I should get rid of that. All right, so the next probability is the probability of me not finding a fireplace, so F bar, and finding a garage. So which one would that be? Well, that would be along this column over here, and it would be along the garage line over here. So it would actually be 30. So the probability of me finding the place or the home having no fireplace and a garage is gonna be 30 out of 100. Plus the final one is that the home actually has both fireplace and the garage. So we're gonna go down the fireplace column and we're gonna go across on the garage row, and we're gonna find out that that condition has 50 houses. So there are 50 houses with both a fireplace and a garage. So if we go ahead and calculate that, that's gonna be 0.1 plus 0.3 plus 0.9, I'm sorry, 0.5, which will equal 0.9. So, or 90%. 90%. Now, one question we have to ask ourselves over here is, do these numbers really make sense? I mean, if I asked you what the probability of that you would find either one or the other in a home, and you get 90%, that seems pretty logical because it's made up of three separate probabilities. Uh, this one being the first, that one being the second, and that one being the third. So, I mean, considering that if we look at the table over here and you really try to think about it, that if I walk into any one of those 100 houses, I'm bound to find at least a fireplace or a garage, if not both. So it seems that that would constitute about 90% of all the homes. So 90 homes out of those 100 have either a fireplace or a garage in them, if not both. So that's how I know that what I've done is actually making sense. So